economists tend to be quite sympathetic to it because it lines up quite well with the way that economists think. It emphasizes the importance of trade-offs, the benefits and costs, pros and cons of different courses of action. And it's applied by governments to making a really wide range of decisions, instituting regulations, building public projects, or creating public goods. But for us, we're going to focus on how benefit and cost analysis can be used to determine the level of externalities so that we can impose Pigouvian taxes, cap levels of goods, or issue damages for things that occur. So here our evaluation is to determine harms in the optimal level rather than just whether some discrete project should be undertaken. So the analyses tend to involve a number of different dimensions, including direct harms, so like destruction of economic resources caused by the activity. And we also have to determine what the market value of that harm is. Second, we have to figure out how things limit the usefulness of economic resources, even if they don't physically destroy them. And that requires assessing the market value of different uses of the resource and determining how that changes as a result of the externality. We also often think about the effects on human life and health, and we'll talk a lot more about that in a minute, as well as on intangible or subjectively valued harms, such as ones coming from some ethical value that you place on society doing or not doing something, or that come from some sort of intangible benefit that you have from having the pelicans out there or something like that. Okay, so a crucial element in evaluating all this stuff, it's purely sort of technical and scientific, and it asks us to think about what are the physical harms and benefits that follow from any given action that creates an externality. And this typically requires a detailed knowledge of a bunch of externalities of creating a nuclear plant somewhere. You have to know what the chances are of the reactor spilling over, how much it harms people if they get hit by pollution, et cetera, et cetera. Or another example of that would be if you want to figure out what the externalities were of setting up a particle accelerator in CERN in Switzerland, you have to know the chances that it's going to blow a hole in the universe or something like that, which some people are claiming. Right? Okay, so chemistry can be very important as well. So if you want to figure out how much does sulfur dioxide emissions cause acid rain, and how much do those in turn hurt crops, you need to know the chemistry of the atmosphere, right? Epidemiology can be very important. So for example, if we want to know what's the externality to other people of you getting vaccinated, we need to know what's the chance of you transmitting a disease, and what are the dynamics after you've transmitted it of it being transmitted to other people, and so forth. Right? So all these things are crucially important, but without sort of some economics on the back end to actually figure out what the value of that stuff is, that's completely useless. So for example, Fukushima was a terrible event, but how do we know exactly how much the value of the land lost in Fukushima was? In order to figure that out, we have to do an economic analysis of what's the market value of that land, how much has it fallen, what could the land be used for before that it can't be used for now, etc. When we think about the effects of acid rain, it's not enough just to figure out physically how much damage they do to crops, but how much they reduce the market value of the crops yielded by the land and how permanently they do so. Right? If we want to think about the value of you getting vaccinated, it's not enough just to know how likely it is that you spread the disease to someone else, but how much harm it does to the other person in economic terms that you spread the disease to them, right? And so almost every study that you'd want to do to think about externalities has to combine some detailed knowledge of the relevant science with some detailed knowledge of the relevant economics. And I'm going to try to show you how those interact today. So probably the most famous economic input into this type of analysis is the valuation of human life. So this is quite controversial because a lot of people will say that human life is just, infinitely valuable. Every human life is, you can't put a dollar value on it. But this is clearly a bit silly because if your life was truly worth an infinite amount to you, you would never drive your car because you take your life into your hands every time you drive your car, right? And so, if you were to drive your car to save $5 on a calculator rather than buying it at the local store, you clearly don't put an infinite value on your own life, right? So that means that as a society, we need to make the same sort of trade-offs that you make as an individual, taking a little bit of risk on your life if you can get a substantial financial gain as a result. How much people are willing to risk their health in order, go ahead.
I mean, could you say that you're not living your life if you're living in a bubble and you don't take any risks though?
I agree.
Okay.
I would agree with that, because that's sort of the point. You're also not living a life if you have only $1 a day to live on and you're barely scraping by, right? So and there's a whole spectrum along there. And so the point is there's a real trade-off between the utility that you earn given that you're alive and whether you're alive or not. And that's the same trade-off that society has to make as well. So, it's pretty obvious that the wealthier people are, the more that they're going to be willing to pay in order to reduce the chance that they die, both because they just have more money to spend on things, and because if you're wealthier, the utility you earn when you're alive is greater, right? And so you're going to be willing to pay more to stop yourself from not being alive, right? And in this sense, a rich person's life is worth more than a poor person's life. And this is something that strikes a lot of people as really unfair. But if you think about it, if you think that's unfair, well, there's a lot of other things you should think are unfair too, right? Why do rich people get to live in bigger houses than poor people do? Why should, if a poor person would rather have a big house and live a shorter life, why isn't that just as fair as having them live a shorter life, or live a longer life but have a smaller house? And so, once you start going down that road, you have to realize that the only way that you can respect the choices that people make in their own lives is by saying that a poor person's life is worth less than a rich person's life if there's any inequality in other things as well. So we may well want to redistribute across people to try to reduce inequalities, but given how much distribution we have, the poor person's life is going to be worth less than the rich person's life is going to be. So there are really three things that we need to measure, therefore, to figure out what the value of different human lives are worth. The first is the value of a life per unit chance that you die. That's called the statistical value of a human life, right? Because there's almost no amount of money that you wouldn't be willing to pay to avoid dying for sure. But if there's some chance of you dying, you'd be, only willing to pay a small amount to avoid that, and that's called the statistical value of life. And we have to figure that out for someone in the population. We're not going to be able to figure it out for everybody because to estimate it, we're going to need some data. We also might, from some other people, figure out what the value of various types of injuries are, like how much is it worth to people to avoid being paralyzed? How much of it is it worth to people, to avoid going blind, etc. And then we need to figure out a way from whoever we measure it to extrapolate it to the rest of the population. We're probably not going to be able to measure the value of the life to millionaires or billionaires. We might measure it to coal workers, and we need a way to sort of figure out how that extends to millionaires and billionaires. And I won't talk that much about that part of it, but the estimates that have been made are that the income elasticity of willingness to pay for life is approximately 0.6 to 0.8. So sort of any estimate that we get, if we get it for someone who is earning $100,000 a year, someone who is earning $1 million a year should be willing to pay about 7 times as much rather than 10 times as much. Okay, so the usual approach to measuring the statistical value of a human life is that you assume that the value that people place on on like bad things happening to them, like getting hurt or dying, is all determined not by the manner in which the bad thing happens, but just by the fact that it happens, right? So in principle, you can imagine that people would be willing to pay much more to avoid being like, tortured to death or, asphyxiated than, dying a peaceful death, right? But if you start imposing restrictions like that, it becomes very hard to estimate this stuff because there's only a very few cases you have. So you sort of have to rule out that people care about how they die. Second, you look for cases where people have actually made a trade-off, where they could have basically paid more or accepted a lower wage in order to get a smaller chance of dying or being injured. And the most classic example of that is dangerous work like mining. It typically pays much better for the same skill level to be a miner than to do other jobs, because people are taking a chance that they'll be killed basically in a mining accident. Or when people decide how safe of a car to purchase, if you can control for a lot of other features of a car and see how much people are willing to pay for greater safety features, that's another approach that you can take. And then you can just look at the difference in price, and that is going to measure the willingness to pay of the person who is just indifferent between the two options, right? Now, the people who choose the safe car probably value not dying more than the people who, choose the risky car. And the people who go into the coal mine probably value their life less than the people who don't go into the coal mine and instead, work at a store. So you're never going to be able to measure how much those people value their life, but you can measure how much this person who's just indifferent between the two professions values their life. Then you have to assume, counterfactually to what I just said, that everyone values their life about as much as the marginal person does, which is a heroic assumption. So there's obviously tons of problems with what I just described, and it would be great if we could improve on it, but this is about all that anyone's been able to figure out as a way to measure these things. And I think the way, as a result, one should interpret these numbers is not as like the number, but as something that's sort of in the right range of the number, right? So the numbers I'm going to show you are on the order of about $5 or $6 million for someone who makes maybe $50,000 a year, and that is probably about right. So it's probably somewhere between $1 and $10 million. It's probably not like exactly $5 or $6 million. But at least this gives you some sense of the order of magnitude of how much people value their lives. And it can rule out crazy values that would value someone's life at $100,000 or value it at $100 million, which are both probably way far off. And in fact, this can be quite useful because there's a lot of government programs that either way undervalue human life or way overvalue human life. And this sort of criterion can be used to rule out both of those extremes. So you can also, in principle, use surveys and ask people how much they'd be willing to pay to reduce their risks, but we'll see that these can be quite problematic, and we'll talk about this in a moment. Okay, so I don't know if you can really see these numbers, probably not very well, but this is like a giant list of studies that have been done, and probably the two most reliable numbers come from this Viscusi paper from the late 70s and this other Viscusi paper from the early 80s, and both of them have sort of 4.1, 6.5. Those were both based on choosing different occupations. The estimates that have been done based on people's choices of cars are quite similar, so those all seem to be agreeing on a number somewhere in the range of $5 to $6 million for someone who's like a median person in the United States. It's probably a little bit higher now because wages have gone up, so my guess is it would probably now be